Solving exponential equations. 5 to the power of x is 125. So we know x is equal to 3 because 5 cubed is 125. That's fantastic if our solution turns out to be a nice, neat integer. 4 to the power of 2x plus 1 is 1 on 2 root 2. I mean, this we can handle because we could rewrite both sides as base 2. So we'd have 2 squared to the power of 2x plus 1, and on the right hand side we've got 2 to the power of negative 3 on 2. So we've just got 4x plus 2 is negative 3 on 2. We get the answer straight away. That brings us to our change of base formula. Handy for a couple of reasons. I think one of the reasons is because you couldn't put every possible base on your calculator. We only have base 10 and the natural bases on our calculator. Sometimes we might want to change it to those bases so we can use a calculator, for instance. 7 to the power of x is equal to 32. Not quite as neat, because how do you write 32 as 7 to the power of something? I could say x is log 32 base 7. So I could rewrite it that way. And now I can change the base into something I can play with. So it'll be log 32 over log 7. I can now go to my calculator. As I say, it doesn't matter whether I use base 10 or natural log, it'll give the same answer, and we end up with 1.781. So we should find that if we went 7 to the power of 1.781, well, we won't get exactly 32 because it's an approximation, but we should get close to it. 3 to the power of x is 5 to the power of x minus 2. This is where we just use the idea, log both sides. Very tricky logging both sides. You just write the word log on both sides. That allows you to bring the powers to the front, and we should now be able to make x the subject of all that. So eventually we get 2 log 5 over log 5 minus log 3. An exponential equation which can be solved like a quadratic. So, I mean, whether you change the pronumeral or not really is up to you. If we let m equal 3 to the power of x, now I'm not saying you would write all this down, but it's easy enough to prove m squared would become 9 to the power of x, playing with the index laws. Basically, we just square the base. So we got m squared minus 4m plus 3. So m is 3 or 1, but of course it's not m we're looking for. We're looking for 3 to the power of x. So x could be 1 or x could be 0. Now, what do we do with inequations then? We can still use these ideas because our exponential and our log functions are continually increasing curves. So when we swap between the two, that order is preserved. Right? So as the x gets bigger, the y gets bigger. So if I have an inequality like this, 2 to the power of x is in between 1 and 32. It would be true if I was to log all 3 numbers, that inequality would be preserved. Okay? The reason being, right, the log curve is continually increasing. So therefore, 1, now imagine you're drawing up to the graph. You got 1, 2 to the power of x, whatever number that happens to be, but 32. 32 you would end up higher than you would with the 1, because it's an increasing graph. So that's what I mean by that is preserved with the inequalities. So we can log them all. On our one, well, log of 1 is always 0. Log 2 base 2 is 1. Bring the x to the front. And log of 32 base 2 is 5. So log base 3 of x is greater than 2. I could exponentialize, if that is such a word, both sides. So 3 to the power of log 3 will now cancel, and we get x is greater than 9. I'll do exercise 2. Jolly good fellow.